After tests are automatically created, you select a failing test, it gives you the expectation and any errors. Then my favorite feature is that it actually shows you a video of what it actually did, with a cursor and keyboard input. It's like hiring a group of testers that want to break your system, to find bugs earlier in the development process. There's a gap in AI coding, a gap which allows software to be released without being properly tested against requirements. This is where Test Sprite comes in. Hiring a testing team isn't financially possible in many cases, so a tool which creates tests for you automatically from your requirements document is a game changer. Test Sprite has a free plan and a 1-month free starter plan with generous credits. The starter plan is $19 and is a great plan to get your feet wet with. It comes with 400 credits and has state-of-the-art models. The application we're going to be testing is my open source LLM benchmarking tool. You select multiple models that you want to use for your use case, then it runs all of them in parallel with the same prompt. This allows you to see if a model is nerfed, or if it's not performing well on the day, or for your area. It gives you the tokens per second and the latency of the model. If you go into the Test Sprite MCP server page, you'll see that they have a detailed docs page. Test Sprite allows a coding agent like Cursor or Klein to thoroughly test your code. This is done by taking your project's description document, reading your code base, creating a standardized project requirements document, then creating back-end and front-end tests. It supports a range of IDE like Cursor, GitHub Copilot. To get started, sign into your Test Sprite dashboard, create your free account, then retrieve your API key. To retrieve your API key, on the left pane under Settings, click on API Keys. Then click on the new API Key button. Give your key a name. Then once the key is generated, store it in a safe place like a vault. If we go back to the docs under installation, you'll see that under other IDEs, there's a standard JSON payload we can use to set up the MCP server. We're going to copy it and paste it into Windsurf. Just replace the API key with the key you copied earlier, then refresh the MCP list in your tool's MCP management panel. You'll then see the tools the Test Sprite offers, like bootstrapping tests to prepare to create detailed tests. Test Sprite will then create a number of front-end and back-end tests to test your entire application. The prompt is rather simple, and we can use it as it is from the docs. Help me test this project with Test Sprite, or something similar. I'm going to paste the prompt into Windsurf, but you can use any of the supported coding tools which are connected to the Test Sprite MCP server. State-of-the-art models work better and faster. As you can see here, Claude 4.5 calls the Test Sprite Bootstrap tool immediately. Then you'll be presented with a page whereby you can choose whether to run back-end or front-end tests first. Then you specify the localhost port your application is running on and just make sure that your application is running. You'll need to also have a product requirements document, even if it's simple. If you don't test Sprite, we'll be unable to create a standardized PRD document. So I'm going to create a simple project requirements document using the AI coding tool. After receiving the upload confirmation, the window will close and Test Sprite will be able to create your standardized PRD document. It will also create a config file, which contains settings like the type of test to run and the project's root path. If we look at the standardized PRD, we can see that it's very detailed, as though a project manager consulted with multiple business analysts. After the PRD, you'll see that tests will start to be created by Test Sprite through an MCP tool call. If we go back to the MCP page in Test Sprite, we can see that our tests have started running, and it runs tests in parallel to optimize the time. If we go back to our Git source control changes, we see that Test Sprite added a ton of different tests. I pushed all the tests to this open source repo on GitHub so you can see how they look, along with how the standard PRD looks like. Now, after the test run is completed, you'll see that you have an option to go into each test and view its details. If we go into one of the tests which failed, you'll see that our application doesn't have a valid health endpoint. If we go to another test, on top of the test description and logs, we can see that there's a video. Then my favorite feature is that it actually shows you a video of what it actually did, with a cursor and keyboard input. It's like hiring a group of testers that want to break your system to find bugs earlier in the development process. After the test executes, it collects console logs and other relevant logs to give as much detail as possible, without being too verbose. Now that Test Sprite has created the test report, we can tell our coding agent to fix failing tests. One of the biggest bugs, which I didn't notice, is that the API just stops running after some API calls. A bug which I wouldn't have noticed if it wasn't for Test Sprite. Test Sprite also groups test failures, so you don't have to run all tests on each iteration. For example, the second group of tests are tests which fail, because the benchmarking UI allows one model, but the PRD shows it should allow multiple. I prompted the coding agent multiple times to create tests, and it never creates such human-like tests. Another bonus feature of Test Sprite is that it can run test in a schedule. For that, you'll need to create a test list. Under testing in the left pane, select test list, and give the list a name. Then click on Add Tests on the top right. Select Start New Test, and give it your API endpoint. After clicking Next, it will create a detailed test plan which includes group tests like functional tests and error handling tests. Then after clicking on the next button, it will execute the tests in parallel. You can specify your deployed endpoint so it can run without your local server running. Then for schedules, you click on the monitoring button on the left pane, then new schedule and give it a name and time range. After saving it, your regression test will run in a schedule as you push changes to source control. In conclusion, as we are now in a fast-paced coding era, let's remember the quality of meeting the initial product requirements and prevent regressions through functional tests.